Tell us a little bit about yourself.
All right. I'm currently attending Southern Methodist University in Dallas. I'm pursuing my degree in mechanical engineering. I was able to meet my CEO that I work for right now in high school. I did the NASA High School Aerospace Scholars when I was a junior, and went to the Johnson for a few days, and I absolutely loved it. Like I said, that's where I met my CEO. I spent some time talking to him while he was doing some electrical engineering for a few projects that NASA had going. And really ever since then, I fell in love with the whole realm of space, the research behind it, just really the drive that I've seen at this conference is very inspiring. I really feel inclined just to get out there and start telling people that just because the shuttle program is done, just because NASA's slightly fading out of the picture, it's really not the death of aerospace. It's in fact the antithesis. It's just about to start really picking up, and you can just see so many people that are just so excited to pour their funding, pour their time and souls into just furthering the human presence in space, and I'm just really excited to be part of it. Our company has a website up. It also has a mobile version, so if you want to type it in on your Android or iPhone, it would be www.solarsystemexpress.com. If you go there, you can find out all about the projects we have going. We have a few more that I didn't mention, and definitely check it out. It's some good stuff, and feel free to just join the movement. Commercial aerospace is really taking off, and I'm glad to be part of the companies that are spearheading the way.
Tell us about your company.
All right. Well, Solar System Express is dedicated to providing imperative small devices and software to bigger companies that are seeking to extend human presence in space. We're mostly doing this by providing hardware and software that would provide niche roles in the exploration in space. For example, one of our products, it's going to be called Martian, which is an acronym for Mars Astronaut Rover Autonomous In Situ Navigation. But essentially, it would be an interface which would be used to navigate by telling longitude and latitude based on geometry found in star patterns, various moons, and the time of sunsets and sunrises. And ultimately, it would almost take a role that's previously filled right now on Earth by GPS systems. But the added advantage to the Martian system is that when you were on, let's say, another planet like Mars or the Moon, and you want to navigate, there are no GPS satellites on those other bodies, so you'd really need something else to rely on. And when you're relying on algorithms and not satellites, it's a lot more friendly in other environments. So that's really what we're trying to do with that.
So let me understand this. You're taking essentially a picture of the sky, and that is telling you, because of the time, because you know what time it is, the position of various bodies in the sky can extrapolate into the exact position that you're at anywhere in the solar system.
Yes, the way that works, I'll use Mars for an example, because our company is very interested in progressing human presence to Mars. For example, the two moons on Mars, Phobos and Deimos, they're located almost exactly over the equator to Mars. And so if you were to take a picture of the sky and it knew what time it was, and it located the two moons, it would be able to tell you, based on the amount of degrees that the moons were off-centered, where you were in retrospect to the equator. And once again, the real benefit there is you're not relying on any sort of satellites that aren't really there. So it's just purely geometry and looking at the sky and using markers. So, yeah.
What kind of camera mechanics are involved in that? Because you couldn't take a 180-degree picture to get horizon to horizon of the sky all at once in a 360-degree plane. So if you're focusing on a particular portion of the sky, how does the software and the algorithm know what position you're at that time? Or do you take a series of pictures, one right after another, and then collate that data?
Well, it would rely more on singular pictures as opposed to like a panoramic. The way we do this is the hardware that we're designing right now that's going to house the Martian software. It's equipped with several things that tell the software other parameters. For example, we're going to integrate technology referred to as a fiber optic gyroscope. And so essentially it works much like a regular gyroscope would, but when the camera is tilted a certain angle, or this way or that, it'll detect through the fiber optic gyroscope the incline to the angle to the horizon, and it'll incorporate that data along with the geometry of whatever's in the sky, and really just whatever image the camera is getting from the sky. The star patterns are always the same, at the corresponding times, and that coupled with the information that the camera is taking in through alternate sensors, that's really what provides the accuracy we're looking for.
And I guess you'll be able to try this out on Earth, won't you? And check it by GPS.
Mm-hmm. Yeah.
So it makes the test and retest cycle rather.
Yeah, one of the big perks to this technology is the duality that it possesses in both its space applications as well as the one it can fill on Earth. We'd actually be looking to market something like the Martian to outdoors lovers, mariners that don't necessarily want or can rely on GPS. They want to revert to a more old school effective method of just looking to the stars for navigation. We'd also be looking to try to get Boy Scouts into it, try to get an electronic sextant badge, because really that's what it almost is. It's a way of just like refining the sextant, giving it some new features, supplying some modern algorithms to it, and just really making it more effective.
How far are you along in the development cycle of the product?
Well, for the software, we've made a little headway. We've been focusing on, in terms of the hardware department, we've been focusing on another project of ours called the Gravity Development Board. And ultimately what that is, it's a high-level board that you can integrate into most series of robotics. And we're really looking to take something complicated like lines and lines of code to tell a robot to do something, and just really simplifying it to the point where we're providing a GUI for people, let's say, that don't have the kind of experience that you would normally need to program a robot. It provides them with a method of just dragging and dropping certain commands and really getting the robot to do what they want it to without spending hours. Instead we're turning those hours into minutes, and providing the whole robotic experience to, let's say, like middle schoolers, that they just have to look at a command, drag it here, and then your robot's going to do exactly what you want.